Hello everyone! Today I'm going to talk about arithmetic and geometric sequences. Both sequences are simply patterns, what is happening from one term to the next. Here's a list of numbers. How can we figure out what type of sequence it is? What do we do to negative 8 to get negative 5? You add 3. Negative 8 plus 3 is negative 5. What do we do to negative 5 to get negative 2? Again, we add 3. Each time, we add 3. If we wanted to keep going to find the next term, we would add 3 to 4 and get 7. To find the next term after that, 7 plus 3 is 10. The pattern keeps going. You always add 3. If we wanted to go backwards, negative 8 minus 3 gives us negative 11. We can verify negative 11 plus 3 does give us negative 8. This is known as an arithmetic sequence, because we are adding a constant number each time. You could also subtract a constant number each time. Let's say we're given this problem. Find the 10th term. How many terms do we have here? 1, 2, 3, 4, 5, 6, 7, 8. We currently have 8 terms, and we want to get to 10. So we can just add 3 2 more times. 10 plus 3 is 13. 13 plus 3 is 16. So the 10th term would be 16. Now, what if we were asked to find the 43rd term? You can continuously add 3, but as you can imagine, that would take forever. Let's find a way to generalize this so we can easily find the nth term. The general equation for arithmetic sequences is the same as linear equations, y equals mx plus b. The m is the common difference, what we are adding each time. In this case, we are adding 3 each time, so let's plug that into our equation. X is the term number, we'll worry about that in a second. To find the b value, we need to find the 0 term. If we assume negative 11 is our first term, we'd have to go backwards to find what the 0 term is. Negative 11 minus 3 is negative 14. That means our 0 term is negative 14. Let's plug that in. We get an equation of y equals 3x minus 14. This is our general equation. Let's plug in 10 first to show how it works. 3 times 10 is 30. 30 minus 14 is 16, which we saw the 10th term earlier was 16. Now let's find the 43rd term. 3 times 43 is 129. Minus 14 is 115. That means our 43rd term would be 115. This is all there is to arithmetic sequences. Let's try another example. Here's our sequence. Find the 30th term. Here's the general equation again. What is the common difference, our m value? What are we doing to 14 to get 8? We subtract 6. Does it work for the next one? 8 minus 6 is 2. Okay, we're good. So let's substitute negative 6 in for m. We need to find the 0 term, our b value. 14 is the first term we see, so we would do the opposite. 14 plus 6 is 20. Our equation is y equals negative 6x plus 20. Now let's plug in 30 for x. Negative 6 times 30 is negative 180, plus 20 is negative 160. Our 30th term is negative 160. Here's another sequence. Find the 12th term. What do we do to 16 to get 8? We subtract 8. Does that work for the next one? Uh-oh, we have a problem. If we subtracted 8 from 8, we should have gotten 0, but we have 4. We subtracted 4. These are not the same. Let's think of it in terms of multiplication or division. 16 divided by 8 is 2, so to get 8 from 16, we divide 2. Let's see if that works for the next one. 8 divided by 2 is 4. Now, instead of a common difference, we found the common ratio, since we divide by the same number each time. This is called a geometric sequence. The general equation for geometric sequences is different from arithmetic sequences. It is in the form of exponential equations, y equals b times m to the x. M is the multiplier. You say, but we divided. We have to convert that to a decimal, so it will be in terms of multiplication. If we go backwards, 8 divided by 16 is 0.5, so each time we multiply by 0.5. b is still the 0 term. If 16 is our first term, you multiply 16 by 2, you would get 32. Let's plug that in. This is our general equation for our geometric sequence. Now let's solve the problem. Plug in 12 for x. It's okay to use a calculator. I know I can't do this in my head. When you type the numbers in, you should get 0.00781. That means our 12th term is 0.00781. Those are the two sequences. Arithmetic is for adding and subtracting. Geometric is for multiplying and dividing. Let's put them together. Here's a few to try. I want you to determine whether the sequence is arithmetic or geometric. Then find the 7th term for each. Pause the video and then come back and check your answers. Okay, let's check our answers. This first one is an arithmetic sequences. So our common difference is 5 each time you are adding 5 each time. Our 0 term is 2. Plug in the equation, you get 37. That's our 7th term. This next one is a geometric sequence. Our multiplier is -4 each time we're multiplying by -4. Our 0 term is also -4. And it's okay to use a calculator on this. You should get 65,536. This one is a geometric sequence. 0.2 is our multiplier because each time we are dividing by 5. Our 0 term is -375. Plug this into a calculator, you should get -0.0048. This last one is an arithmetic sequence. Each time we are adding 20. Our 0 term is 17. Plug in 7, you should get 157. That's all I have for today. Thanks for watching.